Ever wonder how your inbox just knows what's junk and what's not? Well, it's not magic, it's math. Today, we're going to pull back the curtain and actually build a spam detector from the ground up, step by step. We're going to start with literally nothing but a few emails, and by the end, we'll have a smart algorithm that can make predictions, all powered by one core formula. So, let's get into it.
Right, so it all boils down to this question, something we kind of take for granted every single day. How does it work? Well, it's a powerful machine learning technique called logistic regression, and today we are going to get our hands dirty and build one right from scratch.
Okay, first things first. Before a machine can learn anything, we have to speak its language. And that language, you guessed it, is math. So our first job is to take something like an email and translate it into a structured set of numbers that an algorithm can actually understand and work with.
So this is what we're working with. This is our training data. We've taken a few emails and basically just checked for 5 specific keywords. It's super simple. If an email has the word vaccine, it gets a 1 in that column. If it doesn't, it gets a 0. But the most important column here is why. That's the answer key. A 1 means, yep, it was spam, and a 0 means, nope, it was a normal email. This is the exact data our model is going to learn from.
Now, we need to package this up neatly for the algorithm. We do that by creating what's called a feature vector for each email. So step 1, our 5 words become our features, x1 through x5. Simple enough. But then, and this is important, we add a special feature called the intercept, or x0, and we always set it to 1. You can think of this as giving the model a baseline, kind of a default opinion that doesn't depend on any specific words. It just gives it more flexibility to find the best possible answer.
So this slide really sets the stage for the journey we're about to take. On the left, that's our model right now. It is completely clueless. It has these parameters, we call them thetas, 1 for each feature, but they are all set to 0. It knows absolutely nothing. Our goal, on the right, is to use our data and a bit of math to figure out the right values for all those question marks. We're going to turn our dumb model into a smart one.
So how do we get from a dumb model to a smart one? How does it actually learn? Well, the secret sauce is an algorithm called gradient descent. It's the engine that's going to power this whole thing. So let's take a look at the formula that makes it all happen.
Okay, I know what you're thinking. That looks intense, but stick with me. I promise, by the end of this, every single symbol on this screen is going to make perfect sense. This is the update rule. It's basically a recipe that tells our model exactly how to adjust its settings, its thetas, to get better. So let's tear this thing apart, piece by piece.
First up, the theta. These are the brains of the operation. You can think of them as the model's knowledge. For example, if the theta for the word Nigeria ends up being a big positive number, it means the model has learned that word is a strong indicator of spam. If it's negative, it's learned that word probably means it's not spam. And we have one of these for every single feature, including that intercept x0.
Next is that little A symbol, alpha. That's the learning rate. Imagine you're tuning an old-school radio. If you crank the dial way too fast, you're just going to fly right past the station. Alpha is like that. It's a small number, we're going to use 0.5, that tells the model to make small, careful adjustments. It keeps it from totally overreacting to a single mistake.
And now for the real engine room of this formula, the error signal. This chunk of math figures out how wrong the model was. The h theta of x minus y part is literally just the model's prediction minus the real answer. It's the mistake. Then that big E-looking symbol, sigma, just means we add up that mistake across all of our emails. This gives us a single number that tells the model exactly how wrong it was and which direction it needs to go to fix itself.
All right, enough theory. We've got our data, we've got our formula, and our model is sitting there with a bunch of zeros for its parameters. It's time to roll up our sleeves and do our very first training step. Let's do the math.
So first, we need to see what our dumb model predicts. Since all our thetas are 0, when we multiply them by the features for any email, the result is just a big fat 0. We then feed that 0 into a special function called the logistic function, which squishes any number into a probability between 0 and 1. And it just so happens that a 0 always comes out as 0.5. So the model's first guess for everything is a 50-50 coin flip. Now we calculate the error. Prediction minus actual. For the spam emails, that's 0.5 minus 1, which gives us negative 0.5. For the non-spam, it's 0.5 minus 0, which is positive 0.5.
Okay, let's do one update by hand. We'll focus on theta 2, the weight for the word vaccine. So we look at every email where vaccine actually appears. That's email A and email C. The error for email A was negative 0.5, and for email C, it was also negative 0.5. So we add those up to get a total error of -1. Now we just plug it into our formula. The new theta 2 is the old one, which was 0, minus our learning rate, 0.5, times that total error, -1, and a little bit of math, and boom, the new theta 2 is 0.5. Our model just learned something.
So after we do that exact same process for every single parameter, from theta 0 all the way to theta 5, this is what we get. Look at that. It's not all zeros anymore. You can see that theta 2 for vaccine and theta 5 for Nigeria are now positive. The model is starting to think those words are spammy. And look at theta 4 for the word of, it's negative. It's learned that's probably a normal word. Our model just had its first real insight.
Okay, so we've updated the numbers, but who cares, right? The big question is, did that actually help? Is our model any smarter than it was before? Well, there's only one way to find out. Let's run our data through the model again and see what it predicts now.
And wow, what a difference one step makes. Just look at this table. For email A, which we know is spam, the new calculation gives us a score of 0.5. That turns into a probability of about 62%. Since that's over our 50% threshold, we correctly predict spam. And for a non-spam email like B, the score is negative, which gives a probability below 50%. And we correctly predict not spam. It's actually working. 100%. I mean, just let that sink in for a second. After one single round of math, our model, which started as a complete blank slate, can now perfectly classify every single email in our training set. Now, okay, it's a simple data set, but this just shows you how powerful this learning process really is.
But here's the thing. Doing well on data you've already seen, that's like acing an open book test. The real test, the true measure of a model, is how it does on brand new data it has never seen before. This is the whole point, right? This is what makes it useful. So let's do it. Let's imagine a brand new email just landed in the inbox. We'll call it email K. We have no idea if it's spam or not. It's up to our newly trained model to make the call.
So first things first, we have to turn email K into numbers, just like before. So we scan it and see that it contains the words vaccine and Nigeria. That means it gets a 1 for its intercept, a 1 for X2, a 1 for X5, and zeros for everything else. And that Y column? It's a big question mark. That's what we need to figure out.
Now the prediction part is way easier than the training part. All we do is multiply our learned theta vector by this new emails vector. And since most of the emails features are 0, a lot of this math just disappears. We're left with 0.5 times 1 for the vaccine feature, plus 0.5 times 1 for the Nigeria feature. Add them up and you get exactly 1.0.
For the final step, we take that 1.0 and we plug it back into our logistic function to get the actual probability. The math works out to 0.731. That's basically a 73% chance that this thing is spam. And since 73% is way over our 50% cutoff, our model makes its final call. This email is spam. And that's the entire journey. We started with a model that knew absolutely nothing, just a string of zeros. We showed it a little bit of data, we applied one learning formula one time, and it actually developed an understanding of what patterns might mean spam. And then it used that brand new knowledge to correctly classify an email it had never, ever seen before.
Now we did all of that with just one single update. In the real world, this process happens thousands, millions, even billions of times on huge amounts of data. So the thing to think about is this. If our simple model got this good after just one step, how much smarter could it get with 1,000 more, or 1,000,000 more,